Hi, my name is Nathan Guzman, and I'll be explaining how to construct the Lewis dot structure for this compound, so COCl2. So what we're first going to do is count up the total amount of valence electrons, and how we do that is we look at them individually. So that's step one of our three-step process. So there is 1 mole of carbon, and we're going to, in order to find that, is we look at our periodic table, and we notice we multiply the amount of moles by the number of valence electrons, and the number of valence electrons are 4 in this case. So that's a total of 4 valence electrons for this one, and in our 1 mole of oxygen, since there is 1 mole of it, we multiply that by 6, because oxygen has 6 valence electrons by looking at the periodic table, and that is 6. And we have 2 moles of Cl. Now, we're going to multiply 2, since that's the number of moles we have, the amount of chlorine molecules we have, by 7, which is the amount of valence electron in each chlorine that we have, and that equals 14. So we're going to add them up to get our total valence electrons, which is, we count that up, that's 24. Knowing that we have 24 individual ones, if we divide that by 2, 24 by 2, we know we should have 12 pairs of valence electrons. So, step 2 is figuring out which one's the central atom. And our central atom, if we look up top, is supposed to be the one with the least amount of valence electrons. As we see, it's right here. So it's our carbon. So, let's take note that C, our carbon, is going to be the total amount of valence electrons. Now, oh, that's my bad. Erase that real quick. Okay. So, step 3 is our skeleton model. Now, our skeleton model is just to figure out it's kind of like our work to prep for our answer, right? So we are going to draw them out individually. So C would be in the center, and it has 4 valence electrons. And we complete them like so. You know what? I'm going to do it in a different color so it's easier to see. Yeah. I like that idea. I'm going to do it in red. Okay? Now, we know that oxygen will occupy one of these sides. So oxygen here. And let's just write it out for now. Let's not do anything yet. Actually, that was incorrect. That was the shorter way to do it, but let me do it correctly. This is how you're supposed to draw them. Individually first, then come back around. Good. Good thing I caught myself. Okay. So, and we now know that chlorine has 7 valence electrons, and it will occupy the other sides. So chlorine be here, and there'll be a chlorine right here. So, yeah, good. So, 1, 2, oh, my bad. Let me change it to red so you can easily see it. 1, 2, 3, 4, 5, 6, 7. Now, let me just correctly put it here. Okay. 1, 2, 3, 4, 5, 6, 7. Good. Now that we have that situated, we figure out where they bond. So, as we take a look here, we noticed that carbon will bond with one of the electrons here and one of the electrons here, creating a double bond. This creates a single bond, and this creates a single bond as well, making this the correct answer, because they all complete the octet rule, which is that there must be 8 valence electrons present. So, as we write our full answer, the answer is C. There's a double bond with oxygen, and they leave 2 lone pairs on the side. Single bond with chlorine here, and that leaves 3 lone pairs there. A single bond again, chlorine, and that is your answer. So it's pretty simple. So let's review. Oh, my bad. So let's review. So in order to construct this compound, we had to count up the total amount of valence electrons, right? Figure out which one is the central atom. Construct a rough sketch of the Lewis dot structure, and then clear everything up through the use of these lines, which show the type of bonding there is. So there is a single bond with chlorine connecting to the carbon, as well as chlorine with the carbon as well, below right here. And the oxygen has a double bond because of honk. 1, 2, 3. For the amount of bonds they must have. Right there. I hope you found this helpful, and thank you.